So what we want to do is we want to find a way to measure the signal coming out of a radio. We're not looking for the acoustic response right now because we need to know what that signal actually is. So once you download Pink Noise from the website and put that on a flash drive, or in fact if you've got CarPlay or Android Auto, you can use a cable, plug your phone in, and that's still exceptionally good quality. You won't have to worry about an MP3 or a WAV file. You can just play it directly off your device. And since it's not going Bluetooth, it's going to even be better. Once again, Bluetooth also has compression, so not recommended, but in a pinch, it'll work for what we're going to do. So Pink Noise. What is Pink Noise? Pink Noise is equal amounts of all frequencies. So I'm going to show you what Pink Noise looks like. I'm going to show you the signal out of this factory Toyota radio over here, before and after correction. But Pink Noise, basically what you're looking for is a flat response. You want to know that because then you know you have a good baseline. So in fact, I think what I'm going to do right now, we're going to be bouncing back and forth a lot. So I'm going to go ahead and go to my computer here. I'm going to switch this over. And Ernie, why don't you go ahead and pull up my laptop? Hey, he beat me to it. So what you're looking at here, this is the output of the right channel of this factory radio. So this should be as flat as possible. There should be no, dips and peaks and valleys. So the signal coming out of that, if we were to measure it, is basically a perfectly flat signal. In fact, I wish I could show it to you. I can hook my phone up and do it a little bit later, but just understand Pink Noise should be a flat signal all the way across. Now that's the right channel, and I'm going to show you something very interesting on this radio because we did this on purpose. If we stop this and go to the left channel, watch what happens. It's a very different response. This particular radio is actually programmed with different equalization curves left and right, and that's something also very important to know. I don't know of any OEM automakers right now that equalize things separately left and right, but if you are doing a one-seat tune, it is very, very imperative you do left and right because they will vary quite a bit. Now, it might be subtle when you watch that change, but if you notice, there's quite a big change in those two graphs. In fact, let's do something a little interesting here. Let's start with the left channel. I'm going to stop this, and I'm going to store this. And by the way, this program that I'm using is called True RTA. It sells for about $100. It's one that does allow you to see both the signal on left and right channels, and you can compare them both at the same time. So now what we're going to do is we're going to go back to the right channel. I'm going to play it. I said go. And I'm going to store it in number 2. Now if you notice the green behind the red, the green is actually the left channel, and the red is going to be the right channel. Actually, it's purple now that I take off the source. So as we toggle these on and off, you can see what a difference there is between those two signals. And here again, it's not so important. In fact, the red right now is going to be the actual source coming in. So there you have the left channel, there you have the right channel, and here you have left plus right. And you notice these changes, the green is where the left channel is actually louder than the right channel, but the right channel is significantly louder overall than the left channel. The reason this is important to understand is if we start looking at, go ahead, Ernie, let's go back to the RTA. If we start looking at these areas right here where we've got a peak in the signal, let's go ahead and take off the back one. So if this is a factory equalization curve, and I use 40 or 50 hertz, which is right here, to set gain, or if I use 1K to set gain, which is right here, you notice up here this is louder than 1K and a lot louder than 40 hertz. So if you set your gains at 40 or 1K only, that radio is going to clip at the higher frequencies. Actually, it's going to clip up here. It looks like about 12 to 14K, which isn't a big deal to me because I can't hear it, but there's a reason why you don't want that. And once again, down here, you see a big change in the frequencies. So the reason that you still don't want clipping, even if this was clipping, clear up here at 20K, a DSP processor does not know how to deal with clipping. They are looking for changes in signal. That's how it works. If there is no change, if it's a flat line like DC, like total clipping, the DSP processor will either fail the setup process or it's not going to process and tune the vehicle right. you still have to know where the loudest frequencies are, and to make sure if you're using a single frequency to set gains. So if I'm going to use a single frequency to set gains on this particular unit, I'm probably going to set it up here. In fact, we can tell you that's actually 12.9K, and this is at 14.4K. And then, of course, these lower signals, if you were especially to use something down here, you're going to have problems because that radio is going to clip at these higher frequencies sooner. That's why with our key lock and our Key 501, one of the setup processes is to do our specific gain match track. Now what we do for the gain match track, it's not one frequency, it is a sweep from 20 to 20K up and down. So it's going to cover all the audio bands of the spectrum, and it's going to tell you if any of those frequencies clip, and the little clip light's going to come on. So you're going to turn the gain up until the 2 clip lights on the key lock go off completely, or of course on the 501, which is the amp that's down here, it's only got 1 light that'll show you clipping because it is a mono amplifier. But once you know you have a clean signal coming out of the source unit, then you can get down to the art of tuning.